Hi, today's notes we're going over 11.2, finding limits using properties and the direct substitution property. So we have 9 properties listed here that we're going to refer to later in the notes. We're going to begin with the direct substitution property. The key here is looking closely at the limit as x approaches a. If a is in the domain of f, then all you have to do is plug a into the function, and that will give you the limit as x approaches a of the function. Let's give it a try. To check to see if we can use direct substitution, we begin by looking at what the limit is approaching. This limit is approaching 2. So our question is 2 in the domain of our function? Our excluded value of this function would be negative 2, but since the limit is approaching positive 2, 2 is in the domain of the function. Since 2 is in the domain of the function, we can use direct substitution. So this limit will just equal us plugging the direct x value into my function. And evaluating. Therefore, this limit is equal to 3. Okay, so we always want to do direct substitution if we can. So we're going to check to see if the value x is approaching negative 2 is in our domain. So our domain of a radical function will be all values where that is greater than or equal to 0. So our question is, does negative 2 fall into those values? Let's check. So we can see that since x equals negative 2 is in the domain, we can use direct substitution to evaluate this limit. So using direct substitution, our limit is equal to 4. Part C. Once again, we look at our value as x approaches 2 and check to see if it is in our domain. So our domain of this rational is all values such that x is not equal to 2. And we get that from saying the denominator equal to 0. Therefore, x equals 2 is not in the domain. So we cannot use direct substitution. We're going to have to use another method. So what we're going to do to evaluate this limit is we're going to manipulate it and factor and reduce the rational to see if we can get something that we can substitute. So factoring the top, I get x minus 2 and x plus 2, and the denominator is x minus 2. Now, if I look at that, the x minus 2's reduce. Now I have something that I can directly substitute. So now we're going to substitute 2 into the limit and get 2 plus 2, which equals 4. So for part D, we're going to go a little bit faster now. If we look at the limit is approaching x equals negative 4, but negative 4 is an excluded value in my domain, so I cannot use direct substitution. I'm going to go ahead and factor the numerator and see if I can reduce. Factoring this numerator is a sum of cubes. So we have x plus 4, and then x squared minus 4x plus 16 in our factored numerator. And you have the denominator of x plus 4. So as you can see, our x plus 4's are going to cancel. And we're left with the limit as x approaches negative 4 of the polynomial x squared minus 4x plus 16, which I can now use the direct substitution method. And that method gives me 16 plus 16 plus 16, which gives me a value of 48. So in sum, we are going to always try to use the direct substitution by checking to see if our limit value is in the domain. If it's in the domain, we just plug in that value into the function. If it is not in the domain, we're going to try to rewrite the function so that way it allows us to use the substitution method. Here's a great chance to pause the video and try one on your own to see if you can get this. So x equals 2 is in our domain, so we can go ahead and use the direct substitution method. Plugging 2 in, I get a value of 0, so the limit equals 0. Okay, moving on to letter F. X is approaching 0 is not in the domain, so we're going to have to do something to manipulate this problem so that we don't have a 0 in our denominator. So since 0 is not in the domain, I'm going to go ahead and manipulate this by rationalizing by the conjugate of the numerator. As you manipulate the problem, do not forget to write the limit for each step along the way. Our conjugate, we get 16 plus x minus 4 times 4, which is 16. And our denominator, we're going to leave it in factored form. In doing that, we have 16 minus 16 cancels, and I'm left with an x in the numerator. Now you can see the x in the numerator and the x in the denominator will cancel as well. Leaving us a 1 in the numerator and our denominator as seen here. If we refer back to our previous page, when we have the limit of a rational function, you can take the limit of the numerator and the limit of the denominator separately. Additionally, when you have the limit of a radical, you pull that radical outside and find the limit of the inside first and then apply the radical afterwards. So we're going to take property 5 and 6 and apply it to our problem at hand. The limit as x approaches 0 of the numerator divided by the square root of the limit as x approaches 0 of 16 plus x plus the limit as x approaches 0 of 4. And now we can use our direct substitution property. So in the numerator, we have the limit as x approaches 0 of 1 is 1. In the denominator, we get 16 plus 0 as the limit as x approaches 0. And the limit as x approaches 0 of 4 is 4. And we can finish by reducing this. So we get 1 over the square root of 16 is 4, plus 4 gives us a value of 1 over 8. In part G, you can see that t approaching 9 is not in our domain, so we're going to do the same thing we did last time and multiply by the conjugate of the numerator. So when we simplify that, we don't forget to rewrite the limit each time as t approaches 9. And our numerator is going to be square root of t times square root of t gives me t minus 3 times 3, which is 9. And again, I'm going to leave that denominator factored because I believe something will end up canceling out. And I can see the t minus 9 and the t minus 9 will cancel, and I'm left with a numerator of 1. Again, I'm going to apply the properties from the first page and take the limit of the numerator and pull that square root outside the limit and also the limit of 3. Now using direct substitution, I get 1 in the numerator, square root of 9 in the denominator, plus 3. So square root of 9 is 3, so I'm left with a value of 1 over 6 as my limit value. Part H, once again, h approaches 0 is not in my denominator, but I see that my numerator is not simplified. We're going to simplify it and see if I can get some h's to reduce. So in distributing the 3 plus h, I'm left with 9 plus 6h plus h squared. And now I can ignore those parentheses because I have like terms, and the 9 and the 9 cancel. That leaves me 6h plus h squared over h. Now I notice all 3 of these terms have an h. So I'm going to go ahead and take an h out of the numerator using a GCF. And now I can see the h in the numerator and the h in the denominator cancel, and I'm left with the limit as h approaches 0 of 6 plus h. Now that is something I can use the direct substitution property, which will give me 6 plus 0, which equals the value 6. Last but not least is letter I. Now letter I looks pretty complicated. I have a complex fraction and I have x approaching 3, which is not in my domain, so I'm going to have to clean some stuff up first. I'm going to start by manipulating my function by getting rid of the complex fraction. To combine the numerators, I need to make a common denominator, so I'm going to multiply the left fraction by 3 over 3 and the right fraction by x over x, which gives me a numerator of 3 minus x over 3x. My denominator remains x minus 3. Looking a little bit closer, but I'm going to go ahead and copy dot flip so that I can get rid of my complex fraction. Okay, copy dot flip, I see that I have something that's very similar. I have 3 minus x and I have x minus 3. Okay, I can rewrite 3 minus x where I pull out a negative, which would give me a negative 3 and a positive x, and I can rewrite that as positive x minus 3. So now I have something that looks very similar to the other denominator, which means that this and this can cancel out, and I no longer have a complex fraction, but a simple one. So now I have a function that I can directly substitute 3 into because it does exist in its domain. So I'm left with negative 1 over 3 times 3, which gives me a limit value of negative 1 over 9. And I'm done. A quick recap, we're going to use direct substitution property as soon as we get a value that is in our domain, and we can use these properties of limits and skills we learned in Chapter P to manipulate the function so that we have something that we can use direct substitution for. Thanks, guys. Have a great day. Bye.